Hello everyone and welcome to the lecture on hyperparameter tuning and Vizier optimization. Introduction to hyperparameter tuning. Hyperparameter tuning uses Google Cloud infrastructure to optimize hyperparameters for maximizing model accuracy. Hyperparameters control the training process distinct from input data used for predictions and model parameters that adjust to their data. Hyperparameters, like the number of hidden layers in a deep neural network, govern the training process and are usually constant during a training job. Automated technologies like Vertex AI hyperparameter tuning make the process of finding optimal hyperparameter settings less tedious than manual adjustments. So you have hyperparameters which control the training process, and you have input data which is used for predictions. So hyperparameters which control the training process influences the model parameters and adjust to the data, and same this input data which is used for predictions also influences model parameters and adjust according to the data. Hyperparameters, for example, number of hidden layers in a deep neural network governs or dictates the training process, and it also sets the structure of deep neural network, because number of hidden layers will decide how the deep neural network overall structure looks like. And working mechanism of hyperparameter tuning. Hyperparameter tuning involves running multiple trials with various hyperparameters within specified limits and adjusting based on trial results. Effective tuning requires explicit communication between Vertex AI and the training application, defining adjustable hyperparameters and target variables for each trial evaluation. Vertex AI also optimizes across hyperparameter tuning jobs, improving over time to make tuning more efficient, particularly for similar models. So you start the hyperparameter tuning with various hyperparameters and you run multiple trials. Based on the trial results, you adjust the hyperparameters within the specified limits, and then finally you end the hyperparameter tuning job. Vertex AI explicitly communicates with the training application, which evaluates in the target variables, and training application also adjusts the adjustable hyperparameters. Vertex AI defines all these adjustable parameters and the target variables. What hyperparameter tuning optimizes and how? Hyperparameter tuning optimizes target variables specified as hyperparameter matrix, commonly model accuracy calculated from an evaluation pass. During a hyperparameter tuning job configuration, a name and goal, which is either to maximize or minimize, which is the goal of each metric, are defined. So you have the name of the hyperparameter and whether that parameter matrix name should be maximized or minimized. The Cloud ML Hypertune package, this is the Cloud ML Hypertune Python package, is used to pass metrics to Vertex AI, assisting in reporting hyperparameter matrix. So hyperparameter tuning optimizes target variables specified as hyperparameter matrix and commonly calculated, for example, commonly calculated model accuracy from every evaluation pass. Hyperparameter tuning defines all those metric name and defines the goal, maximize or minimize. Selecting hyperparameters to tune and types. The selecting hyperparameters to tune depends on individual experience and advice from machine learning communities, and there is no universal rule. The number of hyperparameters choosing for tuning can affect the number of trials required, impacting time and cost. So number of hyperparameter affects the total number of trials, which finally impacts your time and cost of the model readiness. So there are hyperparameter data types. We have double value spec, which is for double data type, and value range is min and max value, and type is floating point. Similarly we have integer value spec, which is integer. Categorical value spec, type is categorical, and then this one is having list of categories. So just think of colors: red, blue, green. So those are the categories. And you have discrete value spec, type is discrete, and list of values in ascending order. Advanced hyperparameter tuning techniques. Scaling can be performed on hyperparameters recommended for double and integer data types with different methods such as unit linear scale, unit log scale, unit reverse log scale. Conditional parameter spec object allows addition of hyperparameters to a trial based on the value of a parent hyperparameter matching a specified condition, making tuning more flexible. The study spec object allows specification of a search algorithm. If not specified, if there is none specified, Vertex AI applies Bayesian optimization, and the other options are grid search and random search. So there are total 3: Bayesian, grid, and random search. So we have hyperparameters, double and integers, which is scaled by unit linear scale, unit log scale, and unit reverse log scale. Parent hyperparameter matches some condition and adds to trial, and that becomes like conditional hyperparameter. Study spec default value is Bayesian optimization if there is no specified, but you can change it to grid search or random search. Hyperparameter scaling types. You have scale type unspecified. No scaling is applied to this hyperparameter. Unit linear scale scales the feasible space linearly through 0 through 1. Unit log scale scales the feasible space logarithmically 0 through 1. The entire feasible space must be strictly positive. Unit reverse log scale scales the feasible reverse logarithmically 0 through 1. Values close to the top of feasible space are spread out more than points near the bottom. The entire feasible space must be strictly positive. Practical implementation of hyperparameter tuning. In absence of hyperparameter tuning, hyperparameters can be set using command line arguments or configuration files in the training application. When using hyperparameter tuning, command line arguments in the main training module must be defined for each hyperparameter. For a hyperparameter tuning job, each hyperparameter to tune must be defined, including its data type and range of values to try. Hyperparameter sets command line arguments and its set configuration files. Hyperparameters can be defined in command line arguments and can be used in the main training module. This is for manual. And hyperparameters define data type. You have to define the data type and define the range of values. Okay, real world example, conditional hyperparameters. Conditional hyperparameters can be used to define different parameters for different training methods, such as linear rate for linear regression and deep neural network. Shared hyperparameters can use the learning across different training methods for tuning, but in some cases, like different learning rates for linear regression and deep neural network, separate hyperparameters makes more sense. Conditional hyperparameters allow hyperparameters to be defined as a graph, facilitating tuning of the training process using different training techniques with their own hyperparameters dependencies. Conditional hyperparameters define, for example, defined for linear regression, something like learning rate for a linear regression, and same for a deep neural network. And then you have shared hyperparameters which can be used learning rate and can be used running rate. So these will be shared, and then you can have separate if it makes more sense. So conditional hyperparameters define hyperparameters graph which facilitates tuning, and the training process facilitates tuning and training process uses different training techniques and has got hyperparameter dependencies. Hyperparameter tuning search algorithm. If no search algorithm is specified, the default Vertex AI algorithm is used. The algorithm applies Bayesian optimization for more effective search over parameter space. Algorithm unspecified is the same as not specifying an algorithm. In this case, Vertex AI chooses the best search algorithm between Gaussian process bandits, linear combination search, or their variants. Grid search is a simple grid search within the feasible space. This is particularly useful when the quantity of trials specified is greater than the number of points in the feasible space. To use grid search, all parameters must be of type integer, categorical, or discrete. Random search is a simple random search within the feasible space. Default vertex AI algorithm is Bayesian. If not specified, you can have algorithm unspecified, and which will be taking into Gaussian process bandits or linear combinations search, and other two options are grid search and the random search. Okay, next is Vertex AI Vizier, and this is the Vertex AI's hyperparameter tuning service. So Vertex AI Vizier, a product of Google Cloud, assists in managing the intricacies of tuning hyperparameters in machine learning models. This is particularly beneficial when models contain numerous hyperparameters, which could make manual tuning an arduous process. Black box optimization, the principle behind Vizier, comes into play when the objective function is unknown or system is too complex to evaluate using the objective function. So Vertex AI Vizier manages tuning of hyperparameters and utilizes principle of black box optimization, wherein you have unknown or a complex objective function. Okay, extended functionality of Vertex AI Vizier. Besides ML models, Vizier's tuning capabilities extend to other parameters like adjusting UI elements for optimal effectiveness. It can be employed within any system that allows evaluation, even those that don't follow a closed form analytical function. This broadens its use case to a wide variety of systems. So, working of Vertex AI Vizier, the process begins with defining a study configuration which outlines the optimization problem at hand. The study configuration is then employed to execute trials using the goals and input value it contains. Each trial is characterized by a specific set of input values that result in a measured outcome relevant to your goals. The outcome of these trials is captured in measurements which can contain one or more metrics and can be added anytime before trial completion. So you have got study configuration which defines optimization problem and it's used to execute trials, which executes with goals and input values, and outcomes is captured in measurements which captures trial outcomes. Search algorithm in Vertex AI Vizier. Okay, so this is a bit of repetition. So by default, Vizier uses Bayesian optimization, and other options include algorithm, unspecified, grid search, and random search. And the choice of algorithm may depend on the nature of parameters and available feasible space. So this is already covered. So Bayesian optimization, and user can specify the other three, but default is Bayesian. Okay, Vertex AI Vizier versus custom training. Vizier stands out as an independent service capable of optimizing complex models having numerous parameters. Its applications are not limited to machine learning but extend to non-ML use cases and other systems including multi-cloud environments. And it's important to note that hyperparameter tuning within custom training is a built-in feature that leverages Vertex AI Vizier. So Vizier independent service for complex model can be applied in machine learning use cases, non-machine learning use cases, multi-cloud environments, and can be used by hyperparameter tuning, which is a built-in feature leveraging Vertex AI Vizier. Use cases of Vertex AI Vizier. In the field of ML, Vizier can optimize elements like learning rate and batch size for a neural network recommendation engine. For non-ML application, it can test different arrangements of UI elements to optimize user experience. It can also help minimize computing resources required for a job by determining the optimal buffer size and thread count. Interestingly, it can even be used in culinary art, such as optimizing proportions of ingredients in a recipe to yield the most delicious result. So this is just some extra information. Okay, so Vizier, this is the most typical use case: learning rate, batch size, and all other. This is just an example list. It's not a comprehensive, exhaustive list. So it can include all your hyperparameters. and UI elements, buffer size and thread count for minimizing resources, and this is some extra. It can even evaluate recipe and ingredients. And that's all. Thanks for watching.